what they've done then to accomplish the fact that obviously we had some answers that had negative 169. What are we supposed to do about that? Is they created something that's called an imaginary number. An imaginary number. So this has no real solution, but it does have an imaginary solution. So there, even though there's no real numbers I could multiply together, they wanted me to be able to do a little bit more with my problems. And it actually works out that if I have a couple of imaginary numbers, I could put them together and get a not so imaginary number anymore, which I knew Boyer was going to love because she's going to be super excited about that.
I love
Today
imaginary
in
things.
7.5, we're going to talk about complex numbers. Complex numbers are numbers that have imaginary numbers and real numbers put together in their answers. So we have imaginary numbers and we have real numbers, all put together to give you the same thing. So when they're talking about the imaginary number, they call it I. So they talk about an imaginary, and they call it kind of an imaginary unit that they refer to as the letter I. And really, it's very helpful, and it's pretty nifty here. And what they would do is say, here's an example. The square root of 4 is what?
2.
Plus and minus 2, right? We're going to work on our plus and minus.
Oh.
So plus and minus 2. Therefore, the square root of negative 4 is going to be plus and minus 2, and then that negative they're going to replace with the letter I. So all we've changed is because there was a negative sign here, they're going to add an I there. And they really do this to make that happen. They say, okay, well, if I were really going to think this out super hard, I could say that that was 4 times negative 1. Agreed? Sure, why not? And the square root of 4 is 2. And then the square root of negative 1, they're going to say is I. So the square root of negative 1, we're just going to replace with the I. So we could do that in pieces every time. We could say, if we wanted to then, the square root of negative 16. And if we wanted to, we could say, oh, well, I am smart and I know that's 16 times negative 1. So the square root of 16 is plus and minus 4. And the square root of negative 1 is always going to be I. But I tended to just skip over that idea and say, oh, then if I had the square root of negative 49, that would be what? 7i. I just think, oh, I'm going to take the negative sign out and make it an I. And then I can just worry about plus and minus the square root of 7 and not have to worry about the rest of it. What would then be the square root of negative 64?
8i.
The square root of 64 is 8. The I makes it negative. And I would want to throw that plus and minus out there because I'm trying to be really smart about it. How are we doing with that part? Okay? That's not so bad. Okay, then, even more excitingly, we can do some other stuff with our numbers. For example, let's see here. We're going to make a little chart. And we're going to say that I equals the square root of 1. Negative 1, sorry. Okay? And then I want you to think about this for a minute. If I equals the square root of 1, I squared would be the same thing as what?
Negative 1 squared.
The square root of negative 1 times the square root of negative 1, or same thing as square root of negative 1 squared, right? Are we agreed on that?
Yeah.
Okay. So, what is the square root of negative 1 squared? Bah!
Oh.
Look at Miss Blair went, oh.
Light
What happens when I
bulb.
take the square root and I square it? They do what to each other? The squared and the square root. They cancel out, right? Just like if I had the square root of something else squared. So this cancels out with this, and what am I left with? Just negative 1. So really, I squared equals negative 1. And all I did was walk you through that so you could see how that worked. I squared equals negative 1. Because essentially, we have a negative 1 and a negative 1. They canceled each other out. At the same time then, we'll do 2 more just to make sure we are on the same path. I to the third would be the square root of negative 1 times the square root of negative 1 times the square root of negative 1. Well, we know that these two equal what?
1, negative 1.
Negative 1. And we know that this one, if I just had one square root guy here, it's the same as
Negative 1.
just the I, right? So we have a negative 1, and then we have an I. So I to the third is the same thing as negative 1I, or just negative I. And I'll show you in 1 second why we even care about that. Okay? And more importantly, if you didn't want to try to even figure out what we're doing, you could just remember negative 1, the square root of negative 1 is I squared is negative 1, I to the third is negative I, and I to the fourth then. Most excitingly, this is my favorite one. What was the square root of negative 1 times square root of negative 1? Negative 1. And then I have 2 more of them over here, so that would also equal
Negative 1.
negative 1. And what's negative 1 times negative 1?
1.
1! Woo! So I to the fourth just equals 1.
The answer's 2.
So that would be why they didn't even bother to go around with all these square root things and the negatives, was because sometimes you can cancel them out to the point where you don't even have an imaginary number anymore at all. Like here, where we just have a negative number, and here, where we just have a positive number. And actually, it's going to all just alternate from I to negative 1 to negative I to positive 1. The next one, if we did I to the fifth, would just be I again. It just keeps going back and back and back and back. When are we going to use this? We are going to use this in a couple different instances. One instance where we would use complex numbers is in adding and subtracting, and we're almost done with the notes, so you're doing a great job. Just hang with me for a few more seconds. If we're adding and subtracting things with complex numbers, they're going to look like this. Something like 2 minus 4i, whoops, plus, that's plus sign in there, 3 plus 5i. I'm going to make this look like a nicer plus sign, so that plus. When we are adding and subtracting, we can only add and subtract like terms. So we have to look for like terms. When I add these, then I'm going to add the 2 and the 3 because they're the same. And then when I'm done with adding my 2 and 3, then I'm going to add my negative 4 and my positive 5 i's. So just like if this had an x on it, we would add those together. We add them exactly the same way. Remember, we don't do anything with our exponents when we add. We treat it just like an x. So we'd have 2 plus 3, which is just 5, and negative 4i and positive 5i, which is going to give me just
I.
1i, or I. And we're done. We don't have to do anything else at all. We just get to say, woo, look at us done. Also, today, with those complex numbers, we are going to be multiplying and dividing. Did I spell multiplying right?
Mm-hmm.
Yeah.
When we're multiplying and dividing, we're going to have something like 2 minus 4i times 3 plus 5i, with no other sign in the middle, because we know two parentheses we're multiplying by each other. When we are multiplying or dividing a pair like this, we come back to either having to FOIL or using our magic squares. Just like we did when we had an X here.
I love that magic square.
I know you do, so I'll use it again.
Thanks.
So if we were going to do that using our magic square, just like we did a minute ago with our X's, and part of the reason we went over that, we'd have 2 and negative 4i, and we'd have 3 and positive 5i. When we multiplied, we do just like we did before. So we have 3 times 2, we'd get 6. 3 times negative 4 is negative 12i, just like if that was an X or a Q or any other letter. 5 times 2 is 10i. And negative 4 times 5 is 20i to what power?
Negative 20.
Sorry, thank you. Negative 20i, and then I heard somebody say squared. And they were brilliant, because it is 20i squared. Because just like if this was x and x, x squared, I and I is I squared. So we're going to put this together to get 6. Negative 12 and positive 10 is going to give me negative 2i minus 20i squared. Is everybody good so far?
Yeah.
All right. And if you went that far, you would get some credit for our assignment. But on the previous page, we just said that I squared equals what?
Negative I.
Negative 1.
1.
Yes, exactly. So really we have 6 minus 2i minus 20 times negative 1. Well, negative times negative is going to make this what kind of 20? Positive 20. Then 6 minus 2i plus 20. Or I could say that was 26 minus 2i, because I can put my just numbers together. So it worked out then that if we have an I squared, we just replace that with a negative 1, essentially change our sign, and then combine our like terms. So we FOILed or we used our magic square to come up with our solution. We're going to replace our I squareds with negative 1. And then we're going to combine, it's always just going to be our numbers or our coefficients, our constants, whatever you want to call them.
Could we rewrite that as just a little chart real quick? Just those, the I,
What?
a little chart or a little thinking map or a little something, just the I squared, just the 4 little rules for I. The I,
Yep,
okay.
yep. Just give me 1 second. We'll do that separate. That way we have a separate little blurb for it. Okay? All right. The only other part then that changes anything different than that is dividing. And dividing is a little quirky with imaginary numbers. If we're dividing, to divide something, we're going to end up with like 7 plus 2i over 1 minus I. So dividing has one extra step in it. And what we do to divide is look at the bottom. So number 1, we're going to look at the bottom. And our goal is to get it to drop out. Okay? Because we really don't want to divide, because I don't really like dividing very much. We want to get our bottom to drop out. So what we do, in order to get the bottom to drop out, is we multiply by what they're going to call the conjugate. It's a nice little vocab word. Really, we only really like the conjugate because it makes the bottom drop out. And it's essentially the bottom with the opposite sign. So the same bottom but with the opposite sign. And we're going to multiply. So that's step one. This is step two. We're going to multiply the top and bottom by that conjugate thing. It's probably even a new word for Boyer, isn't it, Boyer?
Mhm.
So what I mean, sorry, I will slide that up for you. What I mean by the opposite is, I'm going to look at this bottom, I'm going to write the exact same numbers, 1 and I, and I'm just going to change the sign. So this is plus. And if I multiply the bottom by that, I have to also multiply the top by that. Okay? So it's the same. It's 1, it's an I. The only thing that changes is just that little number, or the sign in the middle. Just the sign in the middle is the conjugate. What happens is we're going to end up with 1 squared, and then we're going to end up with I squared, which is -1. Those are going to cancel each other out, and we're just going to have 1 on the bottom. We're just trying to get rid of whatever's on the bottom so we can ignore it. And by multiplying by the conjugate, we do that. And then we can just ignore the bottom altogether. And now we just have a multiplication problem like we did in the last one. So now instead of doing anything with the bottom at all, what we've done is changed it into a multiplication problem. So now we go back to this problem that we had. We ignore the bottom. So I guess we'll put step 3 over here. We can now ignore the bottom altogether. And just multiply the top. And we would multiply the top again either by foiling or the magic square. So all we've done is changed really our dividing problem here by multiplying the top and bottom by the conjugate. This essentially becomes 1, so we don't really care what it is. And we go back to having a problem just like we did in the last one, where we can start back over. Alright, so we will in just a minute go over that eyes thing again just for a second, for a separate little video on the sheet. Other questions that you have, or do you want to try some and see how it works for you? Alright, then let's try some.